Today we're going to extend our understanding of arithmetic series with something called sigma notation. Okay, so first of all, a sigma is a Greek letter, and it looks like this. It's also called a summation, and it is used to express the sum of a series. So it's just another way of doing what we did in the previous lesson. Okay, so for example, this is what a summation might look like. This guy right here. Okay, so notice it's got that Greek symbol, and then it has n equals 1 on the bottom, a 4 on top, and then 2n plus 5 in parentheses next to it. So the way this is read is the sum, so the summation is the sum from n equals 1 to n equals 4 of 2n plus 5. Okay, and that is just the general expression. So if you look over here to the side in this math tip box, it labels all the important parts. So the index of summation is the letter. It's the variable you're using. N, X, J, I. It can be any letter. 1 is called the lower limit, and the 4 is called the upper limit. So upper and lower, just like a a bottom floor and a top floor, upper and lower. And then 2n plus 5 is the general term. And this looks very much like the expression for an arithmetic sequence. In fact, it can be for any sequence, but in this case, that is an arithmetic sequence. So when we're working with them, we do something called expanding the series. So this would allow us to see all the terms. So to do this, we would have to plug 1 in, 2 in, 3 in, 4 in to this general expression. So if you plug 1 in, that would be the first term. 2 would give us the second term. 3 would give us the third term, and 4 would give us the fourth term. And then we could add them all together to find the sum of the series. So the sum of this partial series, okay? So down here is an example of what I just spoke about. So again, you're just substituting in. So let's just kind of jump into a problem and see how it looks. So down here on try these, so part A, we're going to write the terms in the series. So in order to do this, remember a series is when you add the terms. So we're going to start by plugging 1 in, and I'm going to show you this on another sheet of paper so we can kind of see the process that my brain is going through. So when I'm doing this, I'm saying, okay, the first term is 3 times 1 minus 2. So 3 times 1 minus 2, that's 1. The second term is 3 times 2 minus 2. So 6 minus 2 is 4. So when we're writing this, we're going to have 1 plus 4. We're writing the summation, the series, not the sequence. So the series, so 1 plus 4. And then we can do the next one, 3. 3 times 3 is 9, minus 2 is 7. And really, we can tell this is arithmetic because it's adding 3 each time. So the next term would be 10. I can check it. 3 times 4, 12 minus 2 is 10. That worked. The next term would be 13. Again, 3 times 5 is 15 minus 2. Add 3. So we're adding 3 each time. So 1, 2, 3, 4, 5, 6. I need 8 terms. So 19 and then plus 22. So then they want us to actually find the sum. So when we add these all together, we should get 92, providing I have calculated those out correctly. Okay, so this is kind of the process you're going through. You're just plugging them in. So now in part B, it says they want us to go the other way. They want us to actually write the sum of the first 10 terms of this, the series. So we're going to use sigma notation. So this is my series. So to start, we're going to draw a sigma. On the bottom, I'm going to let the variable be n. N equals, well, I'm starting with the first term, so n equals 1. My term number is 10, so I'm going to put 10 as the upper limit on the top. Now, the last thing I have to do is figure out my expression that goes right here. In order to do this, I need to think back to my sequence formula. So remember that's a sub 1 plus n minus 1 times the common difference. So my nth term is found by taking 80, and then we're going to, it looks like, subtract 5 each time. Now, one thing that is a little bit different here is that we typically simplify the general term down to the most simple expression if we can. Not always, but that is a good habit to get into. So 80 minus 5n plus 5. So this is going to be 85 minus 5n, or you could say negative 5n plus 85. It really doesn't matter. You do need to put the parentheses here. If it was just negative 5n, we wouldn't necessarily have to, but because it has two terms, we are going to put parentheses around it. And that right there would be our sigma notation for this particular series. This is just a shorthand notation, okay? So let's look at a couple more problems. So I'm just going to pull up some scratch paper here. So let's start with one such as the summation of n equals 1 to 5 of 3n plus 1. Now, we can do what we just did up here on part A, where we had to find every single term, and that would definitely work here. If we sat here and said, okay, this is a small enough sequence that we can do that, so 3 times 1 is 3 plus 1 is 4. 3 times 2 is 6 plus 1 is 7, and so on. So it looks like we're adding 3 each time. 10, 1, 2, 3, 4. And then we could take and add these all up. So let's see, we got 20, 30, 46, 50. So 50 would be our answer, providing, again, I have done that correctly. I am going to show you a way to check this on the calculator. However, don't become too dependent on that. But before I do so, let's try it another way. We can check our answer using what we learned yesterday, or in the previous lesson, I should say, which is S sub n equals n over 2, the first term, and plus the nth term. Whoops, it got a little off there, sorry. So if we are using this particular formula, we would need to fill in what we know. So if we're trying to find the sum of the first 5 terms, n is going to be 5. Now, we would have to find, we're going to pretend like this piece isn't there, okay? So we're looking at just the summation piece. If we're looking for the first term, we would just plug 1 in here. So 3 times 1 is 3 plus 1 is 4. And then the fifth term would be 3 times 5 is 15 plus 1 is 16. So this would give us 5 halves times 20. So this would be 5 times 10, which is 50. So S sub 5, yes, equals 50. So notice same answer. Here I expanded it all out, which wasn't too tedious since there was only 5 terms. But if I was looking at maybe 20 or 30 terms, that could get very difficult very quickly, and we don't want to take up time. So this would be our formula that would come in handy. Now, another way that we could do it is we can actually use our calculator. Again, do not become dependent on the calculator. You really need to know how to do it by hand, either expanding it out or using the formula. But this is a good way to check, or if you're in a time crunch, you can do the work here. So to do this, you can either go to Math, or I prefer using F2. So alpha F2. And you find what's called the summation key. So on mine it's number 2. If I press enter on that, it brings up the summation here. So I'm going to start by saying, instead of using n, I'm going to use x. So I'm going to say x equals 1. And then I'm going to arrow up and say 5. So just like my summation is here, I don't know if you can see that very well. And then in my parentheses, I'm going to type in 3x plus 1. Okay, so it looks almost identical to what I have written here, but instead of an n, I'm using an x. And then I'm going to hit enter, let the calculator do its chugging, and notice we got 50. So that is 3 ways you can expand it. You can use the formula we've used yesterday, or you can use the calculator. Okay, but again, don't get dependent on the calculator. So let's try another one. Here, maybe we can just put it right here. So the summation of n equals 0 to 50, and we'll use the same formula, 3n plus 1. Now this one is different. First of all, I don't think expanding it is going to be very fun because we have to go all the way from 0 to 50. But the other thing that makes this particular problem different is that we're not starting at 1. We're starting at 0. With summation notation, you do not have to start at 1. Okay, so what that means is we are going to want to use this formula over here, but we're going to have to modify what we're putting in. Okay, so because again, I don't want to do all those terms up to 50. So what we have to do is we're saying, okay, still thinking about our summation formula, so n over 2, but we're not starting at 1, which is what we normally start at, which means this n value isn't going to be 50, okay, because it's actually going to be 51, because there are 51 numbers from 0 to 50. We have to add one more. A way to kind of get this algebraically, I guess you might say, is to use j minus I plus 1. So what this is, j is the upper limit, I is the lower limit. So notice all I'm doing is saying, okay, if I take the highest number and subtract the smallest number from it, and then just add 1. So that's where I got that 51 algebraically, but you can also think about it with common sense. To go from 1 to 50 is 50, so if I'm going from 0 to 50, I have to add one more number, so 51, okay? Now, instead of saying the first number, I'm going to say the 0 term. So I'm going to plug 0 in here. So 3 times 0 plus 1 is 1. And then I'm going to plug 50 in. 3 times 50 is 150 plus 1, so 151. So this is going to give me 51 over 2 times 152. I'm going to be a little lazy and do this on the calculator. So 51 divided by 2 times 152, which gives me 3,876. So this should equal 3,876 using the mathematics. Again, I'm not going to expand this to 50 terms. I could, but that would take a very long time and we don't want to waste our time. Now again, using our calculator, which we're going to check to make sure we've done it correctly, we're going to do alpha F2, option 2, type in x equals 0 up to 50, and then 3x plus 1. And when I hit enter, notice I have gotten the same exact answer. Okay, so the calculator will give you the right answer, so if you're not sure if you're doing it correctly, you can check. Okay, so that is kind of the big part of today's lesson. So I'm going to give you a chance to try some problems. So if you will please attempt for me number 4 and number 6. So go ahead and try those on your own. And when you're ready, turn the video back on. All right, the answer to number 4 is 345. So this one was pretty straightforward as you were starting at the first term and counting up to the 15th term, which makes using our formula very efficient. So 15 over 2 and then 2 plus 44. When you multiply that all out, you should get 345. And hopefully, if you have a graphing calculator, you did check this, okay? Now, on number 5, a little more work here, but we should have gotten 135. So notice that we're looking at 6 terms from 5 to 10. We have to find the 5th term and this 10th term, add them together, multiply by 3, and that gives us 135. Okay, so hopefully you have those correct. If not, make a little note so you can ask me questions about it. And now I would like for you to try number 8. So this time you're going to actually write the notation for me. All right, so on number 8, you should have gotten the summation of n equals 1 to n equals 7. Now, remember, you just put the number on the top. So on bottom, n equals, on the top, just 7. And then the expression 4n minus 1 in parentheses. Because if you were trying to figure this out by hand, you'd start by putting the first term plus n minus 1 times, and we're adding 4. And then, of course, just multiply this out to get that 4n minus 1. Or you could say negative 1 plus 4n. It really does, the order does not matter here, okay? All right, so 2 more things we're going to talk about. We're just going to kind of summarize everything we've done in this kind of arithmetic sequences and series part of our chapter. So first of all, this right here, this number 7, we're going to talk about the different pieces. So instead of labeling item 4, we're going to label item 8. So just a reminder that the n is the index, okay? The 1 is the lower limit. The 7 is the upper limit. And this expression 4n minus 1 is the general term. Okay, so anytime you have that terminology, make sure you know what it means. Okay, so again, back to summing up, sorry. Up here at the top, we are going to summarize all the formulas that we have been using. So the first one is define the common difference. So you probably don't use a formula, but if you needed to, you could. The common difference says that you take the term, so like maybe you're looking at the first and the second term. Take the second term and subtract the first. So a sub n minus 1 minus a sub n. Okay, that is the formula for the common difference. Just do second minus first, or fifth minus fourth. Okay. To find the nth term, we're going to say a sub n equals the first term plus n minus 1 times the common difference. Okay, and then to find a sum of terms, so the series, okay, the series would be s sub n. There's actually two equations. There's n over 2 times a sub 1 plus a sub n. That's one we've been working with today. Or if you wanted to memorize this one, you could actually use n over 2 times 2a sub 1 plus n minus 1 times d. Okay, it's just kind of your prerogative. Okay, I was finding the nth term by hand and then plugging it into this formula. So this one's a little bit easier to remember, so that's the one I tend to use, but you're more than welcome to use the second one. Okay, so that is it for this video.